Right, this is Math 154, Perspective Matters, and this is the third homework, ratios, proportions, and scale factors. So I brought up the notes, and we want to talk about a couple different items, and the first one being this idea of a ratio. So a ratio would be comparing any two quantities to one another, and then it can also be done as A to B or an actual fraction. So say I had a recipe that needed a 3-to-4 ratio of eggs to flour. Okay. That would mean if I was putting in 3 eggs, I would needed to put in 4 cups of flour, for example. And I could also write that as 3-to-4, but use it as an actual fraction as 3/4. So a couple additional real world examples. Like I just said, the ratio of eggs to flour. But you could also do when you're creating an antibiotic is different ratios of amoxicillin to clavulanic to treat different things. Like one ratio might be for an ear infection, another might be for strep throat, and it just depends. So what a 16-to-1 ratio would look like is I would be saying that I need 16 units of amoxicillin, whatever I'm measuring it as, to 1 unit of clav. And then say I wanted to do this 2-to-1, that means I'm mixing a little more amoxicillin with that 1 unit of clavulanic. And then another one could be, that's augmentin, but then we might also say if you just need to give amoxicillin, maybe we give it for 125 milligrams per 5 milliliters of suspension fluid, something like that. So if you could think of a couple others, you might want to consider that. And then for a couple application of ratios. So ratio is just a comparison of two quantities. Okay. A rate then is a ratio of two quantities as well. So in terms of a rate, if we think about common rates that we know, something like miles per gallon, that's a rate. So it's just some ratio of two quantities again. So your ratio is the comparison. This is the actual ratio. And then when a unit rate is it's a rate with a denominator of 1. So think back to driving. You might say you're going 60 miles per hour. And that means you're going 60 miles for every 1 hour. That's a unit rate because it already has a denominator of 1. But I could also tell you that we're going 120 miles every 2 hours. That's just a regular rate. So that's the difference on the unit rate versus regular rate. Obviously, with cars, we tend to go 60 miles per hour versus, oh, you're going 120 in 2. Another good use for these unit rates would be if you're going shopping and you're seeing different items in different quantities for different prices. And this unit rate would make the most sense because I want to see which is a better deal. So I can do this 2 ways. I can either do dollars over ounces, or I can do ounces over dollars. Just consider which one you're doing. Usually what we would want to do is this price per ounce. Which is this first one. So this first idea of price per ounce, that way we can see how much each ounce is actually costing us. So I have the unit dollars on top divided by ounces. So I'm going to put my dollar on top. So it's $1.98. Oh, my pen seems to be doing something. So it's okay, so I have this $1.98 for 24 ounces. So what I'm going to be left with is a price per 1 ounce when I divide these two numbers. So this comes out to 0.0825 or approximately 8 cents for every ounce. Then I'm going to come over here and do it for this other one. This one, make sure the ratio stays the same though for that unit rate. So I'm going to put money on top. And I'm going to put my ounces on the bottom. And I'm going to divide. So if I do my 4.97 divided by 67 ounces, plug that in real quick. I'm getting 0.07417 per ounce, or approximately 7 cents an ounce. So in that case, your 67 ounce is the better deal per ounce, because it is a little bit cheaper. Okay, so this next item is this idea of a scale factor. So if I'm looking over here at buying this Batmobile, which is known as 1/6 scale, that means that the scale model is 1/6 of the original one. So I'm doing corresponding lengths for two similar geometric features. So that means that each piece here is going to be 1/6 of the original. So if the dimensions are 39 inches long, then we're going to multiply that by 6 to get the original one back. So I'll come back to scale factor in a minute, but first let's review a little bit about proportions. So a proportion is any two ratios that we're going to set equal to one another. So for a little bit of the algebra behind it, if I have two proportions, I can do what's called cross multiplication, which means I can take the bottom from one and multiply it by the top of the other. And then I'm going to come over and do the same here. And this only works if you have two ratios with an equals in the middle, no adding and subtracting within them. Okay, so I'm going to do like this, divide by 4. So x is equal to 40 divided by 4, which is 10. Another way to look at this is 5 over 4. If I go to 8, I'm doubling the least common denominators, that 8. So 4 to 8 is double. So double 5 is 10. Just depends. And then with math, the good news is you can check your work. I can put this back in. 5/4 equals 10/8. 10/8 reduces to 5/4. So I have an equal amount. So it's just a different way of writing the same thing. But I can also use that math to figure out what my missing one is. So what you would want to do here is go into breakout rooms or try this in class. So after you've done that, your instructor will go through those.